Hello, everyone. Welcome to lesson 3. In lesson number 2, we learned about the brief history, the current developments, and the future of artificial intelligence. And we had a test just yesterday, and you did also very well, further reconfirming that open and distance learning delivery system that we apply in the National Open University of Nigeria emphasizes the parity with the on-site mode. This lesson number 3, will be looking at artificial intelligence, associated technologies, and terminologies. Everywhere you turn today is AI, 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 AI. And you see those AI experts, there are plenty in this room. They are the best in the world. They will be talking some big grammar, some terminologies, some jargons. So this ABC of Artificial Intelligence Module 8 course. So what we want is to be able to let you know as simply as possible what these terminologies and technologies mean. Today, Your Excellencies, ladies and gentlemen, is the 17th day of February. It's a Saturday. The regular day for bringing you a lesson is a Monday. But this is unique, and you see. So we are on to artificial intelligence, associated technologies and terminologies, as I said in the introduction. Oh, this is my nursery school class, and they're asking, look, what is generative AI? What machine learning? They're asking all these questions. For me, my dear children, is that me, I know be Google. You should learn how to learn. You should go and find out what all these terminologies mean, and then in class, we'll just enjoy ourselves through some additional explanation. But because we have a short time in this class, maybe 30 minutes at most, I'm going to just gallop through these terminologies and technologies. So what's the objective of this lesson? You only to explain in as simple manner as possible all of these terminologies and technologies relating to artificial intelligence. Over the last several decades, I've been doing my best in my research to see how students learn. And why is that necessary? That's necessary because we've been making efforts to break down the barriers to students' learning of science and other subjects. So we came up with this approach. It's called the Cultural Techno-Contextual Approach, CTCA. You can find details of it at ctcapproach.com. Of course, I can make this book available to you for free. Why am I bringing this up? I'm bringing this up because we're talking about learning. We're talking about artificial intelligence, and this book has quite some chapters relating to that. So look at the questions the nursery school students are asking me. What is this? What is that? But you see, there's what we call the information processing apparatus in the, if you like, head or body of any of these learners. They are receiving information from me when I'm talking now, as I'm talking to them, writing on the board or using some apparatus. And what is happening is that nervous system is at work. Yeah, the cerebrum, and all of this. Our professors of medicine, plenty in this course, they know it all. I am just a novice in these matters. So you see the some kind of vertical section through the human brain. You can see different areas. That is not for you to, it's not going to come out in the test. So don't bother yourself about it. But what is important here, why I'm bringing this up, is that look at this student or the learner, these students in the nursery school class that have asked me all these questions. They are getting information from their 5 senses, the sensory data. As the data come in, the data are processed through their neurons, through the nervous system, through the brain. And within the brain, you have the working or executive memory. And then it moves on to short-term memory if there's some rehearsal. And there's more rehearsal, more practice, and all of that. It goes to the long-term memory. This is figure 3.3 in my book, Information Processing Model. Now, so you get the fuller details of this memory here. So what are the scientists? What are these computer scientists? What are we trying to do now? What they are trying to do, or we're trying to do, is to move, or since antiquity, do God, what God has given to us, transfer it to machine. So, and it has to follow the same process, more or less. So let's start with one of the terminologies or technologies, and that is neural networks. You see, we have the biological neural network. You know, I showed you the nervous system, brain, spinal cord, and the peripheral, and all of that. See, that's the biological neural network. Now, the computer scientists and the statistician, because that has to do with big data, it has to do with mathematics, mathematical modeling. They have these artificial neural networks trying to model what God has given to us in machines. So, what is an artificial neural network? What's a neural network? In this case, artificial neural network is an architecture, a computing architecture that tries to model how a human brain functions. You know, I told you, you have the nervous system, you have the neurons, you have the signals will pass, jump through the synapse and go to the other neuron and all of that kind of a thing. So a neural networks are made of a collection of processing units called nodes. You also have that in the human. So this thing, now transferring human to a machine. And I tell you, when machine don't learn well, machine can face us and tackle us. And only yesterday on BBC, on actually the major international channels, you got to hear that people are afraid of elections coming up because we're going to use technology to fake people. In the American environment, you have some people that put the Biden there, they put so it's something else. So that's a matter for other discussion during the course of this course. These nodes, pass data to each other, like transferring. It's just like the human too. I'm sure you did some science or biology in school. Just like how a brain, how it works in the brain. Neurons pass electrical impulses to another. So this is how the thing looks like. You have the input layer. This is a neural network. You have the input layer. You have the output layer. Let me give you a classical example. If I want to log in to my mobile app, to my bank, GT Bank. Now, small money I get there. I'm a retired professor. So even if I'm not retired, now only $261, not Nigerian professor at the end now. But me, I know. But let's assume I want to get in there. I already told the system, the GT Bank system, I'm sure you all are familiar with this kind of operation. Say, hey, biometrics, if you see my face, facial recognition, then, so the thing captures it. And so what is the image? Anytime I come and I say, okay, now you validate me, it will not go through all of this, several hidden layers there. And it outputs it and say, okay, this Peter Okebukola, it gives me a tick and you can go ahead and process. So that is that one. Now, there are different types of artificial neural networks. Hey, my dear participants, you don't need to bother yourself with this ABC of artificial intelligence. It is not to give you the full details, but just make a note of all of these types. But at these three, hey, you could come out for exam on Friday. So just learn. I've linked out one question there. Multi-layer perceptrons, MLP. CNN, but note this CNN is convolutional neural networks. This one, the third one, is recurrent neural networks, RNN. So you have MLP, CNN, RNN. I may just give you which one is not, which is not part of this. You don't get that one now. So these are the different types of artificial neural networks. What are they used for? Medical diagnosis, financial predictions, energy demand forecasting process, actually almost everything you can use that neural networks are used for. Let's move on to the next one. The next terminology, excuse me, algorithm. Algorithm. What algorithm? Let me give you, this is the easiest of them. And without this algorithm, forget it. No artificial intelligence anywhere. This is the heart of the matter. An algorithm, okay, look at this. You want to bake a cake. You get a cup, white sugar, butter, chocolate, example, whatever. This one. Or you want to make a bar. You get, say, boil water. I used to like a bar, but not now. Boil water. When it's come to boil, put gari inside it, stir, and then, so step by step. Want to beef steak, one pound. Oh, that's a British thing. I just copied this one. 1 gram or 10 grams of beef steak, a piece of this, 1 teaspoonful of garlic powder. Instructions, thin slices or next, next, next. Without this algorithm, artificial intelligence no go work. And so you are somewhere and they're talking about algorithm, say, you are telling module 8, what is the thing? It's just step-by-step procedure. Don't confuse me. They are shakara too much. All these artificial intelligence people. The thing means only step-by-step way. And let me show you the definition. Algorithm is a set of instructions for solving a problem or accomplishing a task. Or as a list of instructions step by step that are widely used throughout the whole. Yeah, so that is the algorithm. Let's move on to the next one, machine learning. Machine learning. Now, machine learning was coined by this great guy, Arthur Lee Samuel. Arthur Lee Samuel coined it in 1951. And let me show you the relationship. Artificial intelligence that we have been talking about since we started this warm-up activities and go to run till April 26th and forever, because you keep hearing about it, is the bigger concept or bigger phenomenon. Machine learning is a subset of it. And getting deeper in it is deep learning. So this one is like the mother. This one is like, hey, how would I call it now? This one is like the grandmother. This one is the mother, and this one is the child. This one is deep right inside of it. So what is it? Machine learning, acronym ML. It's a branch of artificial intelligence, as you can see on the other page, which gets computers to learn and act as humans. Machine learning provides machines with the ability to automatically learn from data and past experiences, make predictions with minimal human intervention. Big grammar, let me tell you what it means. It means that you have a machine, you train it, it's learning. And then when it has learned up to a particular stage, it can then be deployed to perform some tasks, to act like humans. When you train it more, it's just like training a dog. You train it to sniff, you train it to sit down, you train it to do. So that's what it is. Machine learning is learning by machine. No. Yeah, that's what it means though, that machine is learning. And I've given you the definition here. Now, there are different methods of machine learning. 3 of them. You have the supervised machine learning. That's the one that you supervise. You have the supervised one, the one that you don't supervise. I'm trying to turn the whole thing around. Semi-supervised, you don't completely supervise. But let me give you the more detailed definition. The supervised machine learning uses labeled data sets to train algorithms. I don't encourage people, when you have the thing on the screen, you are doing a PowerPoint projection. Hey, by the way, I got a mail from one of our very great participants who said, look, the last PowerPoint slide that I used, that table is too small. By the way, I use different presentation software. The one there is called Prezi. You can Google it, Prezi.com. Very exciting. So apologize that it was small, but I'm making the thing big now. So I don't like people reading. Use this, label this thing. I just know say that one. I don't know the thing to use. So don't read everything. Just highlight a few points there. So model adjust until it fits most appropriately. What model? The one for the algorithm that is trained to classify data or to predict. The unsupervised one, the same thing, without the need for human intervention. Analyze and cluster unlabeled data sets. And the third one, of course, semi-supervised machine learning. That's between being supervised or not being supervised. If you pause this video, you can see the details there. So how do we use machine learning? Machine learning, speech recognition, facial recognition, like the one I discussed. About 10 days ago, I was coming from Washington, D.C., going to London, and we had, I showed you the picture of we went for this global conference on quality assurance, and when we're coming back. At the airport, nobody has boarding pass. No. You just walk through something. scans your face, and then you go in there. If it gives you a tick and you go in there, facial recognition. And this is also in many places, online chat bots. I'll come to that in a minute. Fraud detection. So these are some of the everyday use. Let's go to deep learning, third component of that. Deep learning was introduced by this professor, Rina Dexter, in 1986. I wished that as I'm narrating this thing, I will come to one that will say deep learning was introduced by a Nigerian or an African scholar. It will happen, but I'm begging us all, let us make it happen. The CTC approach that over 40 years of research that we've vetted as helping to break barriers is now, in quotes, now the talk of the town, the talk of the global world. And so when they label, put that one there, computer science education anywhere, they say by Peter Okebukola. So all of us in this room, in this hall, in this mojo, please and please, let us strive. Let us be known. Let us work hard so that, look at, she's a distinguished professor of computer science at Donald Brent School of Information and Computer Sciences at the University of California, and all of that. So let us move in that direction. So what's deep learning? It's a subset, as you saw the other time, of machine learning that uses artificial neural networks to mimic the learning process of the human brain. This one is deep. This one is deep. This one is deep. Okay, what am I seeing here? Class, so my nursery schools there, what are you saying? You are still confused. Oh, yes. You are confused because I've not got to your, you asked me about expert systems. Don't worry. Oh, you not perfectly understand? That's fine. You need more explanation. Yeah, you were asking about bots. I will get there. You are a good teacher, sir. No, I'm not. My teachers are in module 8. The very experienced ones, there are plenty. Professor Damola Oke, who was acting vice chancellor of last week, there for this place. Professor Ajayi, who is vice chancellor of Wellspring University in Benin. There are plenty. All these professors from University of Benin, University of Ilorin, University of Lagos, Lasu, they are all plenty. They are the teachers who, me, I just learn under their feet. So let's move on to expert systems. Expert systems. What's an expert system? The way it's even the expert system is one way you have an expert. It's a computer system. It mimics or emulates the decision-making ability of a human expert. And it has a number of components, which we are going to see now. What are the components? This expert system. It has a knowledge base. So the expert, am I saying I'm an expert? No, I'm not. I mean, just learning, knowledge from an expert will be poured into this knowledge base. And then there's this rules engine, and then the user interface. This is the user asking the expert something. This is a non-expert user. So it makes a sample input, and then the user interface queries this rules engine, and then the knowledge base will give it a feedback and comes here and it advises the non-expert. So that is the way the expert system works. Is that all? No, it is not. I've only given you a general framework. Like the artificial intelligence professors, computer science professors that are here will know it is a lot more, it's a lot deeper than this. But what is this course for? This course now for just ABC, so that you are not bamboozled by anybody. All of you, all of us here, there are 1,500. Don't be bamboozled. Yeah, you go to a place, artificial intelligence, neural networks, generative AI, and all of that, you're talking. Oh, yeah, that's the object of this thing. So let's go. So there are some components of the expert system, as we just saw. We have the knowledge base, you have the rules of inference engine. You can see what they do here. You may wish to pause this video and get through to understand them more. The user interface, that's the one with the non-expert, and the explanation module. Yeah, that's it. And there are different types of expert systems. I highlighted this knowledge-based expert system because of my deep familiarity with it. They are designed to mimic the problem-solving capabilities of human experts. Of course, we have the rule-based expert systems, the fuzzy logic expert system, the neural networks expert systems. How do you apply expert systems? Information management, hospitals, help desk, the lot that you can share, and a lot more. Let's take a break. When we're on break, we normally have our quiz. Yeah, so this is our quiz for the break period. How many people are on planet Earth today? 7 billion, 7.5, 8.1, 10 billion. And your answer is what? Correct answer is 8.1 billion. Today, okay, actually by yesterday, February 16, 2024, the current world population is 8 billion 0914 and the rest of them like that. So let's look at the distribution. That is showing us that Africa is the second most populous. Asia has 4.7, we are 1.4. But you see, the yearly change in Africa, see them, look at the others, some dropping, minus. Africa, 2.37% yearly change. So that is it. Draw any conclusion that we want from it. But the quiz is world population. So today on this planet we have 8.1 billion people. That brings us to the end of the break. So let us press on to the next terminology. That's big data. Big data, as the name implies, is big. Extremely large data sets that you can analyze to reveal patterns and all the other things to give us some insight into human behaviors. And it has all of these attributes: veracity, variability, vulnerability, visualization value, and all that. So all you need to know about big data is that it's data that is big. How big is big? That is what we there's no minimum, there's no, there is no, how do you call it now, there's no threshold that say okay, anything beyond this. But usually it is highly voluminous data that is processed using very intricate software to get. And big data you have into knowledge-based systems. So let's go to bot. What is bot? A bot is a short form of robot, not robot, robot, also called internet bot. Now, these are computer programs that help us to automate certain tasks. So if you have a bank and you go to the internet and you say, okay, I want to buy, something will come up and say, okay, what do you want me to do for you? And then you ask, okay, I want to know my balance in my account and all that. So those are that's an example of a bot, which is a computer program that operates as an agent for a user or other programs to simulate a human activity. Okay, the ones which you call chat, the chat bots, they can engage you in the chat. That's the type that I said. You go online and something pops up. Say, what can I do for you? That's artificial intelligence. There are some that are put in here. Just give me a minute. Let me see what I can get into one on UBA. All I've done is to say chat bot of UBA. So let's chat with Leo. Yes, let's. I hope this one's not going to waste my time. Okay, that's it. That's Leo. Get started. Okay, yeah, let's go now. Okay, let's see WhatsApp. Yes, let's see the WhatsApp bit. Continue to chat. Yes. Yeah, so this is UBA chat banking. That's Leo there. So Leo, which is the nearest branch to me? Please send your current location from your device's menu or enter a location. Below, it's Agbara. Hey. Yeah, so you can see here the UBA ATM's branches near you. Please select an option. So that's how this chat bot, and it's everywhere. That's how it works. Okay, so what's next? Generative AI. Wow, I love this. This AI can create, that's generate new content and ideas from anything, and it enables you. You can put your input can be text, and you can come with an image or a song and all of that. It enables you to generate new content based on a variety of inputs and this like that. Generative AI, we're going to focus on it in the assignment. This is the heart of the matter. It generates, you want somebody to, you don't want to be in class, you can generate yourself from your image and put the text and all of that, and it generates new content. That's the heart of the matter. Okay. Oh, you now understand perfectly. Of course, you asked about expert systems. I will spend some time with expert system. You are too much. I know. Not too much. I God did too much. When you grow up, you want to be an AI engineer. Oh, yes, that's what you would like to learn. So what have we learned in this lesson? We've learned these terminologies and these technologies associated with AI. What's the assignment? Assignment is straightforward, just like we did for practical number 2. You are not going to write a 3-page essay, not a 2-page one now, on generative AI. If I thought I would have time to tell you about Gemini, everybody, every organization, like Microsoft Edge, they come up with a co-pilot that I demonstrated. I wanted to demonstrate the Gemini. That's the one by Google. Google, no. By Google. It came up with BARD, that is Gemini. Very interesting one. So you can mention Gemini here if you so generative AI. So what I want you to do is write an essay, 3-page essay on generative AI. Simple. You can do this in 3 minutes. Google it, look for generative AI components, make it about 3 pages, copy and paste practical 3 of your personal website, generate QR code, submit the URL, and that is it. I'm going to provide the link. So, and it's a long time. Today is Saturday, Thursday, February 22, 2024. That is when you are submitting at 12 noon. Hey, some people will give an excuse. Oh, internet broke down. Why don't you start now? Internet never break down for you to watch this video. Go now. Just get on to generative AI. So what do we mark? Just the full description of generative AI with examples and images will fetch you, wait for it, 200 full marks. Not a small thing. The QR code, 50 marks. The total, 250 marks. We've done that. Yes, okay. Yeah, so one last thing, and that is I've removed my Vic Bay hat, and I put on my happy birthday hat. As I said, today is 17th day of February 2024. And I'd like to thank all of you, family and friends, that have sent me, especially members of this class that have sent me, and all those that I'm sharing or that I'm sharing February 17 with, that I'm sharing February 17 with. Happy birthday, and thank you all very much. May God keep keeping us in good health. Until lesson number 4, it is bye from me, Peter Okebukola. Bye-bye.